We visualize difficult, complex concepts all the time. Just look at science fiction movies like Star Wars and Star Trek. We have ships moving around through 3D space, enacting complex physics, and it's all visualized seamlessly and cohesively. In popular games, similarly, we spend millions of dollars to make rich visual environments to visualize the complex physics of driving ships and cars and shooting things and off-world and other environments. However, why is it in the year 2022 we don't spend the same time and resources to visualize science cohesively and completely? If you were to take Star Wars and show an animation of the Millennium Falcon, and then have me read a 10-page chapter on what the ship did, and then have me look at some still images of the ship jumping through space, you'd think that was a terrible movie experience, wouldn't you? Wouldn't you think, why don't you just make a complete movie and visualize everything and how it all relates? So why do we teach science this way? And why aren't we questioning it? Why do we still teach science as if it's the 1920s instead of the 2020s? Of course kids have trouble understanding it. How could they not? Let's go over the major issues in STEM education materials today. There are many gaps in core concepts that are not visualized in standard chemistry and physics curriculum. Simulations that are present, which are few, are not guided for students, and so they get overwhelmed by them. Students also can't store their simulation experiments to review and study later, and we all know how important it is for students to review their notes in order to prepare for a test. Why would we assume if you show them a simulation once, they're just going to magically remember what they did? Science concepts which are highly related are not taught using similar visuals and virtual environments, and complex connections are not made explicit. Instead, several separate simulations in different contexts are used, making it harder for students to see how concepts are related. Invisible forces and concepts need special metaphorical visualizations that show changes in the quantity of these forces over time. Think of potential or kinetic energy graphs. Quizzes in simulation design are often not classroom and advanced placement centered. This applies to other course levels as well, such as high school and collegiate chemistry and physics, by feedback from real teachers and students. My groundbreaking research study at Columbia University showed that integrating knowledge of teaching how electricity passes through a neuron resulted in a 500% increase in comprehension versus more traditional means of showing students isolated images and text. And this wasn't even using interactivity, just animations alone. Cognitive science shows us there is a more efficient way to teach complex STEM subjects. Typically related science concepts are taught through several different simulations, which is not as effective as integrating them into one simulation environment to show how they are related. In our AP Chemistry guided sims, we teach many chapters using the same beaker and graph and equation setup to ground students in one stable visualization and help them see how multiple concepts are related, instead of thinking each chapter is something completely different. Let's see AP Chemistry guided sims in action. Graphs, equations, and the beaker are all linked visually for the student across chapters to help them see difficult connections easily. Interactive experiments help solidify these connections, make them more precise and grounded. Quizzes and exercise help the student test what they've learned and prepare for their AP exam. And a beaker character helps guide them through the simulation. Accordingly, the more concepts we integrate visually, the greater the gains. We already saw research that showed integrating neuron concepts resulted in a 500% increase in learning. We predict integrating even more concepts than this study will result in exponential gains in learning. Imagine integrating 100 physics concepts into a single simulation. All the concepts in one course, or 2 or 3 courses. The gains would be truly nuclear. Let's see how the completed AP Chemistry guided simulations will compare against other products, both free and paid. Free science simulations, tutorials online, animations from web and textbooks, and normal classroom instruction will visualize some major concepts in AP Chemistry chapters, but not all. Only AP Chemistry guided sims will visualize all major concepts in AP Chemistry. Free science simulations, animations from textbooks, and normal classroom instruction link some important graphs to visualizations, and just a few complex chemistry equations are linked to simulations and animations. That part also goes for free tutorials you'll find online. Only AP Chemistry guided sims will have all highly complex chemistry equations linked to simulations. We'll link all major graphs and units to visualizations. We'll use similar visuals and environments to teach how concepts and chapters are related. We'll have multiple examples of each concept in simulation format, not just one. We'll guide the student through the simulation, or allow students to rerun and study experiments in special study mode, and has quizzes tailored to the AP exam within each unit with comprehensive explanations and scoring. That last one does occur in normal classroom instruction, and maybe happens in the free animations from the web and textbooks, but that's all you're really getting there. You're not getting a lot of the other features. The AP Chemistry guided simulations are primed to be ported to augmented and virtual reality, gamified, and to integrate artificial intelligence-powered adaptive feedback and assessments to be at the cutting edge of how people learn. Versions of the integrated STEM apps will be retrofitted to teach advanced concepts to middle and elementary students, bridging the gap of what adults and kids can learn. The integrative simulation learning framework can be applied to multiple STEM domains and integrate disciplines such as physics, currently in beta, biology, calculus, statistics, and learning code. Help support the chemistry apps to build and improve a learning framework to revolutionize how we teach all STEM concepts and complex domains faster, deeper, and with greater engagement. Let's get STEM education out of the 1920s and into the 2020s. The integrated chemistry and physics apps will be offered to low-income students, especially underrepresented kids, in the US and worldwide for free and/or low cost, making quality education accessible to all. Please help support our mission by paying for our apps if you can, and if you're a large organization or nonprofit, donating to our cause. Thanks so much. Let's work together to reduce the gap in educational access.